my school determines my pre-calc class as the AB calc class.
Okay. Well, I have some Calc AB exams. If you want to kind of review those, we could.
Okay.
Or if you have specific problems that you want to go over, we could do that also.
You see, I don't know about calc since I was not given any summer homework. I have no idea what to expect.
Well,
all I was told is that it was difficult.
It was difficult? Yeah, you can bet that for sure. Okay, what I have here are practice tests for Calc AB.
Okay.
Okay, so I would think this is probably material that you would know, and if not, let's teach it to you.
All right.
Let's start with number 1. Any idea what the first step should be here? These are not easy, I should warn you. If I had some material that was a little easier, I would start there. But these are fairly difficult, but not that difficult. When you see a single item in the denominator, what does that mean you can do?
As in, like, take it out, like multiply it?
Well, you can treat that. In other words, this is the same question as the limit of 3x squared over 2x. In other words, you can separate out the denominators. Now, I'm going to leave that like that, just because it happens to be very convenient to do so on this problem. But knowing that a plus b over c is equal to a over c plus b over c is important. Okay? And the reverse is not true. A over b plus c is not equal to a over b plus a over c.
Okay.
It's only if the denominator is a single thing that you split it out into two fractions. Okay, and they want the limit of this as x goes to 0. Well, what's the limit of that as x goes to 0? Think of it as the numerator is outpacing the denominator. But you could also factor that. In other words, simplify this. What do you get?
3x over 2.
Right. And what happens when x goes to 0 here?
In the denominator, nothing.
No, just look at this quantity. What happens as x goes to 0?
As it's approaching 0 or when x equals 0?
Well, this is the thing about calculus. Calculus is all about as it approaches. Okay? If it's 0, then the whole thing is 0.
Right.
And as it approaches 0, the whole thing gets closer and closer to 0. So you can say the limit of this is 0. Okay? And then this one over here, we can actually write as, we can factor out the 5. And the only reason I would do that is because their original statement well, if the limit of that goes to 0, what happens to the whole thing?
Then...
No, it wasn't quite correct. I noticed that what they gave us was 1 minus cosine instead of cosine minus 1. Doesn't matter in this case. In other words, I can stick a negative sign there and make it 1 minus cosine.
Okay.
The key part is, what does that go to as x goes to 0?
It goes to 0.
Right. So no matter what we're multiplying it by, whether it's a negative or a positive, the whole thing goes to 0. So we have 0 plus 0. So the answer is 0.
Okay.
Okay? Now, tell me if you've had some of this stuff and if you haven't had. Because you're going to be a little different than my typical Calc AB student. In other words,
Okay.
most of the people that are taking Calc BC have taken Calc AB.
Right.
And I know that the IB program is supposed to be a substitute for that. But in some areas it may be, in some areas it may not be.
You see, my school doesn't offer AB.
Ah, so
It just goes straight
was
into
the
BC.
only choice you had.
Yes, either that or it was AP Stats.
Well, you definitely want the calculus.
Right. So I pretty much had no other choice.
Well,
Since it ran out of math classes.
from what you told me last year when we were working together, is you've had quite a bit of calculus. You have had maybe the first quarter of integral calculus even. And as long as you've had limits and differential calculus and the first part of integral calculus, you're ready for Calc BC.
Okay.
Now, Calc BC is going to start off by reviewing all of the stuff that we're reviewing now. In other words, they're going to review the Calc AB part.
Okay.
So
That's good.
I would think that looking at questions from the Calc AB, the AP exam for the Calc AB, would be the best way for you to prepare for this Calc BC coming up.
Okay.
If you ever have specific problems that they've given you to review, then let me know and we'll go over those. But I think this is probably going to work. Okay, so if f of x is equal to this function, where do we have vertical asymptotes? First of all, look at that function and tell me what we should do first.
Simplify it.
Factor it.
Right.
Factor the numerator and factor the denominator. Well, let's start by the numerator. What can I do very first thing?
Take out 3.
Okay, so I have 3 times x squared minus 2x minus 3. And then the denominator, factor that.
Okay. X minus 2 times the quantity of x plus 1.
Okay. Now, in the numerator, can I factor it further?
Yes.
Do it.
X minus 3 and x plus 1.
All right. So we've separated each into their linear factors.
Right.
And that matters because normally you're going to have vertical asymptotes wherever the denominator is equal to 0. So it would be easy if you didn't factor the numerator to come to the conclusion that x equal 2 and x equal minus 1 were vertical asymptotes. But they're not.
No, there's a hole.
Exactly. There's a hole at x equal minus 1 because of that right there.
Yes.
So the only vertical asymptote is where?
X equals 2.
Yeah. Answer A. This would be an easy one to miss if you factored only the denominator. You want to make sure you factor both just in case something cancels. Sorry for the blurriness of this one. If you can't read it,
I can read it.
okay. I was going to say I can write it down on this, my tablet. You'll notice so far that most of these are pre-calc questions, not even calculus. The limit question was a calculus question, but this is not.
Okay.
What grows faster, polynomials or exponentials?
Exponential.
Okay, so we only have A, C, and D, and E as possibilities. In other words,
right.
This is a polynomial. There's no way this grows the fastest when the variable is on the algebra line and not in the exponent. Now, what happens to this function as u increases?
The denominator becomes larger.
Right, which means the whole thing becomes smaller. So not only does this not grow the fastest, it doesn't even grow.
Right.
It gets smaller as u increases. Well, we've eliminated that. So now the only question is, if exponential grows faster than anything, what's the most important part of the exponential? In other words, which grows faster, 4 to the u or 3 to the u?
4 to the u?
Correct. Even though the 3 to the u has a u to the third, this is a polynomial. And when you're talking about large numbers, in other words, which grows fastest or slowest, you're always talking about the far right end of the spectrum. You know, when the numbers are really large. So this u to the 3 completely gets overridden by this 3 to the u, but this 3 to the u doesn't even come close to this 4 to the u. So that grows much faster than that. Now, let's compare it to 200e to the u. What's the number e equal to? Approximately. Because it's an irrational number a lot like pi. 2.71.
Right.
Okay. Which grows faster between those two quantities?
The 200e?
No. Remember, this 200 is not being taken to the u exponent.
Oh, okay.
That's strictly a coefficient.
Oh, okay. Then it'd be 4 to the u.
Exactly. The only thing that determines which grows faster here is the size of that. This could be 2 billion, and this would still be termed as growing faster. Now, this is probably stuff you haven't had, thinking about it, because even for Calc AB students, this is at the very end of the Calc AB stuff. So, don't feel bad if you don't know some of these. It's quite possible that you haven't had some of these. Unfortunately, I don't know which. But which of the following is true about this graph? Hold on, let me... So you just pretty much have to read each answer. And this is also a terminology question. I don't know that you've had all of this terminology, but you can probably still figure out the correct answer.
Which I'm guessing is E?
Yeah. Yeah, a jump discontinuity. It's definitely not continuous there. It is continuous here, incidentally. It's not continuous here at 2, but that's not called a jump discontinuity. So, what does instantaneous rate of change mean?
The rate of change at that moment?
Which is first derivative.
Okay.
If you could only use 4 words to describe first derivative, those would be the 4. It represents the instantaneous rate of change. Notice that with anything pre-calc, you don't have anything called instantaneous rate of change. All you have is average rate of change. If you go to Colorado Springs and it takes you an hour and it's 60 miles, then your average rate of change is 60 miles per hour. But you never speak of instantaneous rate of change. Why? Because rate of change is rise over run. Well, at a particular moment, if I have that curve and I want to know what the rise over the run is at that point, well, the rise is 0 and the run is 0. So rise over run is 0 divided by 0, which is a real problem. And that's kind of why calculus was invented, was to have answers to 0 over 0. But we have an easy answer to this problem. If the instantaneous rate of change of c is the first derivative, what's the first derivative of that function?
8.6 plus x?
And evaluate that at 300.
308.6.
Now, these problems they love on the AP exam. The reason they love them is because you can't write a function, which means you can't easily differentiate it, you can't easily integrate it. All you have is a table measured at discrete intervals. In other words, we know what was happening at 0 minutes, 5 minutes, 10 minutes, and so forth and so on. But we don't have a function that defines this. And yet, we can still use calculus to do this. Go ahead and read the question.
Okay.
How much drains in the first 10 minutes? Answer A.
Well, in the first 10 minutes, it'd be 1,500.
Okay, write that down. And in answer B, the next 10 minutes.
1,200.
And from 15 to 25?
Oh, 15 to 20. Oh, 15 to 25. Okay. 1,000.
And 25 to 35.
900.
And finally, 30 to 40.
800.
Which is the least of those numbers?
Ah, shoot, I forgot to write it down.
800.
Right.
They all got smaller. In other words, 0 to 10 was 1,500, and we kept getting smaller and smaller and smaller. So this problem really wasn't the calculus problem either.
Mm-mm.
Just was talking about the thing that's important to calculus, which is rate of change.
Right.
What's the limit definition of first derivative?
Limit definition.
In other words, officially, I know we have the power rule, and we have the product rule, and the quotient rule, and the chain rule, but all of those were developed from the limit definition.
Oh, the limit as h approaches 0 is f of x plus h.
Very good.
Plus
Minus
minus f of x over h.
Yes. Now notice that the top, the reason that's a minus is because that's the rise.
Okay, yeah, rise over run.
Yeah, well, if I have a function like that, and I pick a point x, and then I pick a point that's h away from x, well, if I want to figure out what the slope is at that point, what is that? This is f of x plus h, right? And this point here is f of x. So when I calculate rise, it's the difference of the two. That's why it's f of x plus h minus f of x.
Right.
And the run is actually x plus h minus x.
But that cancels that into h.
Yeah, and that leaves just h. So that's how you get that formula. It's the slope of the secant line as it approaches the tangent line.
Okay.
And that's probably the essence of derivative calculus, is the slope of the tangent line, which means the same thing as the instantaneous rate of change. And that's what's so critical about calculus, is it allows us to calculate instantaneous rates of change, which we can't do with algebra. Algebra is rise over run. Well, you get 0 over 0. That's not very helpful. So that's why the whole concept of limits was invented or discovered, whichever way you look at it, and how we calculate the first derivative, how we calculate the slope of the tangent line, or the first derivative, the instantaneous rate of change. So if we apply this definition to here, what do we get? Which answer?
For the function f of x equals x squared. So ay caramba. At the point 2, 4, so
what's wrong with A? Let's eliminate him.
okay.
What's the problem with A? What's in the denominator?
4,
which
would not be h.
Okay. So we're only interested in answers that have h in the denominator, which is b through e.
Right.
Now, does this fit the description? Is that f of
No,
x
since neither of them are squared.
h? Well, that one's squared. So is that.
No, it's not supposed to be squared.
Well, yes, it is. The original function is x.
Oh, right. Okay.
So
then
f of x plus h squared.
But is the limit supposed to approach infinity?
Well, now hold on. Excuse me, hold on, I wrote that wrong. That's how I would write that. That's what f of x plus h is x plus h squared. And they're asking us to evaluate it at this point, so I'm going to fill in 2 for x. So 2 plus h squared is correct, minus f of x, which is 2 squared, is correct, divided by h is correct. The only problem is h is supposed to be going to 0.
Right,
So
not infinity.
B would be totally correct, except h is going to infinity, so we need D.
D.
So far, these questions that feel right? Too hard, too advanced, or too easy?
They seem somewhat easy right now.
Easy, okay.
But like, I just need reminder stuff so I could remember.
Fine, because these will get harder for sure as we go through them. So this is a good place to start on the easy slopes. Okay. So how am I going to take the derivative of this? Take a look at that function and which part's the easiest part to differentiate.
17 pi.
All right, we know that goes to 0. That's a number. That's not a variable, that's a number. So the only part we have to differentiate is this part and this part. Which rules are we going to use?
Product rule.
Okay, let's do the first part. What's the product rule say? Now, there's more than one way to memorize this because you have the associative property in play. Right. So, and I never know which my students are memorizing. To me, I do that times the derivative of that plus the opposite. If you want to do it the other way around, that's fine. Just tell me what it is.
I think I remember it as 1d2 plus 2d1.
Which means 5x times the derivative of secant x. In other words, it doesn't matter which way. As long as you're adding, you can have item A plus item B, which is the same as item B plus item A. So let's just start with 5x times the derivative of secant x. What's the derivative of secant x? That's one of the that's one of the tougher ones to remember. It's secant tangent. Plus, what's the reverse of that?
Plus secant x. Well, 5 secant x.
Okay. And then let's do this one over here. It's also the product rule. And let's use the same pattern. It goes here. It's the derivative of cosine.
Oh, sorry, negative sign?
Okay.
Right?
All
right.
And then what's the reverse of that?
Plus 3x squared cosine x.
All right. So now, if we try to put all that together and see if I can simplify it. Here, let me do this. All right, let's see. I can factor out a 5 secant x from the first part. And, I haven't even looked at the answers yet to see whether they're factored or not, but I automatically factor.
Yes.
Just because that's usually the way they present their answers. Okay, this turns into a minus. So that's minus x cubed sine x. This is still plus. And I could have factored out something from that also. But before I do, let's look at our answers and see what we're looking at here. Well, let's see. We know A isn't right, because it's still got the 17th pi.
Right.
B
They don't look simplified.
B doesn't look simplified nor correct. So let's look at what we started with. 5 secant x plus 5 secant tangent x, that's all of that, plus, there's the 3x squared cosine x minus x cubed sine x. D looks correct. D looks like that.
Right.
All right. This is going to be a bunch of chain rule applications.
D in, D out.
Okay. So we got the sum or the derivative of the sum, which means we can take the sum of the derivatives. So what's the derivative of that?
Since it's chain rule, first finding the derivative of the inside, which is 6.
Yeah, let's start with a different problem. I want to go over the differences between this.
Oh, sorry.
That's okay. No, hold on. This is very important. Just a second. This, if you have any difficulties at all with the chain rule, this should clarify. What is the inside of that one?
X.
It's sine x. In other words, let's go through what we would make u equal to. Well, we would make u equal sine x, and then we would have u squared, right?
Oh.
That's how you figure out what the inside is.
Okay.
In the bottom one, what's the inside?
X squared.
Right. So I would let u equal x squared, and then I would have the sine of u. And the thing is, I know how to differentiate that, and I know how to differentiate that. So you just have to figure out what the inside is. Well, we've got a couple of insides up in this problem. We have the inside that's sine of 6x, and then we have the inside of that inside, which is 6x. So we're going to have to apply the chain rule twice here. So what's the derivative of the outside? In other words, if I said to you, what is the derivative of the sine squared of u? What would that be?
10 cosine of u?
No, it's 10. In other words, use the power rule. There's the power rule applied.
Okay.
Times the derivative of the first inside. Well, the first inside is sine of 6x. Well, the derivative of that is cosine of 6x. And finally, we have the second inside, which is 6x, and the derivative of that is 6. So this is the derivative of this part of it.
Okay.
Okay. And let's just stop for a moment on that, and let me ask you this question here. What's the derivative of that? First apply the power rule to the outside.
Okay, 3 cosine squared of 4x.
Right, and it's important that nothing else changes. In other words, when you're applying the derivative of the outside, all you're doing is applying the power rule. Now, what's the derivative of the first inside?
Negative sign of 4x.
Right, negative sign of 4x. Again, change nothing other than you're taking the derivative of cosine of u, whatever u is. And finally, the derivative of the last inside?
4.
So that's how we do when there are multiple chain rule. I don't know how much exposure you got to that. But the biggest thing to remember when you're doing the chain rule is what would you make the inside? If I had this and I wanted to differentiate that, what's the inside?
E?
Oh, it's that. In other words, if I let u equal 3x, then I'm going to have to differentiate e to the u, which I know how to do. That's e to the u. So the goal is to turn it into something that you know how to do, that is familiar. Okay.
Right.
So if I'm differentiating e to the 3x, I get e to the 3x is the derivative of the outside times the derivative of the inside is 3. How about this? It's the derivative of the outside. Or what would you let u equal? That might be the more appropriate question. What would I let u equal if I... In other words, you get the chain rule by actually doing this process. It's only been simplified to the derivative of the outside times the derivative of the inside because it's easy to remember that way. But it's important to know what substitution was really made. So u would be what?
7x?
Yeah. In other words, I know how to take the derivative of u. It's the cosine of u. Well, u was 7x. And now the derivative of the inside?
7.
Mm-hmm. And we're always going to write that with the 7 in front, like that. Because it's definitely not the same as the cosine of 49x.
No.
So if you write it like this, it can be confused. You write it like that, it can never be confused.
Right.
All right. Let's see. Did we ever come up with an answer to this? I don't think we did. I stopped right in the middle. So if we continue here, so all we did was take the derivative of the first part. What's the derivative of the second part? Still a double application of the chain rule.
Right. 10 cosine 6x times negative sine of 6x times 6.
Good. All right, so if we go to simplify this, what do we have? We have 60 sine of 6x cosine of 6x plus minus, you're correct, minus 60
cosine 6x sine of 6x.
What's the answer?
0.
Uh-huh.
Huh.
If I was taking this test and I had no clue as to how to do this problem, that would be my guess. Just because it's such an unusual answer. And that has nothing to do with teaching you calculus. That just has to do with taking tests, multiple choice tests. All right. Where do the zeros take place on this h of x function? No, excuse me, that's not the correct question. That would be here, here, and here, and here.
Right.
The question is, where do the zeros take place on the derivative of this function?
-3, 1, and 4.
Very good. In other words, where the slope of the tangent line is 0.
Right.
That's the key. I'll switch pages here. I have to leave this one. It takes a while to see all, it takes a lot of room to see all the answers here. So only expand it to a certain point. It's saying which graph is the derivative of this graph. Another very popular question on the AP exam.
Okay.
In other words, it's not all about just taking derivatives of functions. There's an awful lot of graphical stuff involved.
Okay, so the peaks will be at 0 for the derivative.
Okay, so what does that allow us to do?
Eliminate.
So that should be 0. Eliminates A, eliminates B. Oh, no, hold on just a second. Notice what they did here. They did a horizontal translation. In other words, the vertical axis on these 5 answers is not under the vertical axis here.
Oh, I can't see it that well.
Okay, well, the reason that's important is because you can't just drop straight down. If your first derivative graph is below your function graph, then it's relatively easy to just say, well, I need a 0 there. I don't see it there, don't see it there. But if I interpret this properly, I should have a 0 at -1 point something. So I can certainly eliminate A, but C looks like it's -1 point something. And D looks like it's -1 point something. And E does not. So it appears to be between C and D. And where's another 0?
At 2? Wait, no, not 2. The point something in between 1 and 0 and...
So about a half. So A we already eliminated, so we're not going to consider it. B gets eliminated. There's no zeros. between 0 and 1. C is a possibility. D is not. C is the answer. Okay, now, one other thing I want to show you that I find extremely helpful to all of my Calc students is this graph. This is a graph of a function, its first derivative, and its second derivative. And I might have already shown this to you. I probably did, because I show it to most of my students. The beauty of this is that the y-axis is underneath each one. I mean, they line up vertically. Because this is increasing from this point to this point, what should the first derivative be between those two same points? Very key calculus concept. If the function is increasing, the first derivative is positive. And you can see that the first derivative is positive. It's above the x-axis between those 2 points. The fact that it's decreasing is immaterial. If this is increasing, this has to be positive. Well, this hits a 0 right there, so the first derivative is 0, and then it starts decreasing. Well, from this point to this point, the first derivative needs to be negative because the original function is decreasing. Well, it is negative. It's negative, it's below the x-axis. Finally gets back to its 0 point, where that is the slope of the tangent line is 0, and then the original function increases for the rest, and the first derivative is positive. So this first derivative graph matches up perfect with this original function graph. Now, this is the second derivative. Same rules apply. Second derivative of the first derivative. Well, second derivative of the function is the same thing as the first derivative of the first derivative. So, if we're looking at the first derivative and it's decreasing from there to there, then the second derivative better be negative that whole way. And it is. Notice it's below the x-axis that entire way. Its 0 is the point where the slope of the tangent line is flat for the first derivative. And then the first derivative starts increasing again, and the second derivative is positive the rest of the way.
Right.
So these relationships between original function, first derivative, and second derivative are critical that you understand when you're taking calculus.
Right.
Okay, cool. Let's see. What time do we start? 1 o'clock? Yeah.
Yes.
All right, so we got about 10 minutes. Let's see here. Where did we leave off? We left off at this one here. So let's go to 500. So here's our graph. And they're saying which of these 5 statements is true. Is A true?
No.
No, because it's concave up right there.
Right.
It's also concave up down here. Well, it's concave down right here. So B is clearly not true also. How about C?
No. What? Yes.
Yeah, it's concave up for everything to the right of that little hand there. And it's concave down between -1 and 1. So that's actually a true statement.
Yes.
And D is obviously false because here it's concave up.
Mm-hmm.
E is, it's rare that E, it's rare if you're taking a multiple choice test, and I don't care if it's calculus or ACT or whatever, never guess. It cannot be determined. I've never seen that be the correct answer. You know what I'm saying?
Mm-hmm.
There's a lot of questions where they give you that as a choice. Your answer cannot be determined. Well, don't ever guess that. Unless you have, a good reason to believe that that's it. If you got it narrowed down to that and something else, maybe, but...
Highly unlikely.
Right. Okay, you had implicit differentiation? If you didn't, let's go over it. It's not that hard. Most people have trouble with it, and they really shouldn't. If I was explicitly differentiating this, I would have to solve for y, correct?
Right.
And then use either the product rule, the power rule, the quotient rule, or whatever. Well, it's actually much easier to implicitly differentiate this by taking the derivative of the left side with respect to x and the derivative of the right side with respect to x. Now, when I'm taking the derivative of the left side with respect to x, the only rule I have to follow is that if I run into a variable that's not x,
add an x prime?
A y prime. Follow it with
Y prime.
Y prime. In other words, when I run into this first thing, I just do it standardly. That's 2x.
Correct.
I could follow that with dx, but that's 1, so I don't need to write it. Second one, I'm going to take the derivative of the outside. But
y.
Yes, dy dx, always. If this variable is anything other than this, I always have to follow it with that.
Okay.
And I might be taking the derivative of this function with respect to t. And t isn't even in the function.
Right, so that'd be...
I would have to follow this 2x with a dx dt. Yes, exactly. Okay, and now what's the derivative of the right side?
0.
Okay. So now if we solve for this, let's first of all solve for dy dx, and then we're going to look for places where dy dx is equal to 0. Okay, so what's dy dx equal to?
Negative 2x divided by 8y.
Okay, let's make that look like that. What's the only thing that makes that equal to 0? When you have a fraction and you say that has to be equal to 0, it's only ever equal to 0 if the numerator is equal to 0.
Right, so x equals 0?
Correct. And that's the only tangent line we have.
That would make y equal 2.
What's that?
If you plug it back in, that would make y equal 2 if you plug it back into the original equation.
Right. You're correct. And in fact, there's more answers than that.
Positive 2 or negative 2.
The answer to this is not 0. The question is determine the number of points on this curve whose correspondent tangent lines are horizontal. Well, before we go through all the calculus, what kind of curve is that from a conic section?
Circle?
No,
No, not a circle.
Same coefficient. That's an ellipse.
Right, an ellipse.
It's either this kind of an ellipse or this kind of an ellipse. Both of which have how many horizontal tangent lines? 2. The horizontal one has a tangent line there and a one there. And the vertical one has a tangent line there and a tangent line there. All of which are horizontal.
Alright.
So regardless of whether that's a horizontal or a vertical ellipse, and we'd have to do more math before we figured that out, it doesn't matter. They both have 2 horizontal tangent lines. Now, notice that the way I did it was to find out where on the x-axis we have horizontal tangent lines, and I came up with only one spot, 0. Well, that horizontal tangent line is at x equals 0, and so is that one. And so is that one, and so is that one. So just because we come up with x equals 0 is the place where those horizontal tangent lines occur, doesn't mean that the answer is 1 or 0 for that matter. It just means where on the x-axis it occurs. Well, it occurs at 0, but it happens to occur at 2 places. So being able to recognize that curve as an ellipse, as long as you know it's an ellipse, all ellipses have 2 horizontal tangent lines, regardless of their orientation. Even if it was rotated like that, that's going to have a horizontal tangent line there and there. So the moment you recognize that that's an ellipse in whatever orientation, you know the answer is 2.
Right.
But the way to figure that out is to implicitly differentiate that and solve for dy dx, set dy dx equal to 0, and figure out where those horizontal tangent lines occur. Not that this needed you to do that, but like I said, we're not preparing you for the AP exam, we're preparing you for Calc BC. So.
Right.
All right. It's probably a good place to stop.
Okay.
And yeah, I'm recording this, and I'll continue to post it to my YouTube page just like normal. I think you have that address. If you don't, let me know, and I can send you a link to it.
All right.
And it always takes